Hello, my people. Hope we're doing well. Uh, this problem I passed on when I was discussing it with Ethan on Wednesday because I made an arithmetic mistake and I passed on it and said, well, I'll figure it out, once class is over. And yeah, remember how I said at the end of the last one that even your teachers occasionally make rookie mistakes? Yeah, this was a rookie mistake. But basically what we need here is this winds up being, 101 degrees, this is 3/8, and this is 3/4. Notice that you cannot make a full ratio, and therefore you need to use law of cosines. And so c squared is equal to a squared plus b squared minus 2ab cosine 101. Okay. Now, this is one of those ones where if you want to deal with decimals, that's fantastic. You just get down with your bad stuff. Okay. I don't want to have to deal with that, so I'm going to go ahead and make 3/8, and I'm going to store it into a. And I'm going to we'll just put 0.75 since that's b, and we'll store that into b, and therefore I'm going to get a squared plus b squared minus 2a, 2ab times cosine of 101. And I got 81, and this is what I got the last time. And then basically what you do is you take the square root of that, and you wind up with 0.900. Okay, so c is approximately 0.900. I got that, and I was fine with it. But then I went on to law of sines, and I made an arithmetic mistake, and I'll show you what I did. Let's go ahead and look for sine of a. So we need sine of a, and that's over 3/8. And then it's sine of 101, and that's over 0.900. Being careful that when we actually do our calculator work, we don't use 0.9, but we use the full value. Basically, I got my synapses crossed, and of course, this dividing by 3/8 is 8/3 sine a. The problem is that if I'm trying to push it over to the other side, it's not 8/3. I need to multiply both sides by 3/8, right? But I multiplied both sides by 8/3, and I wound up with a sine expression equal to a ratio that was much larger than 1, because I was multiplying it by 8/3 and not 3/8. And that was the mistake that I made, and I was kicking myself afterwards. But like I said, it should be freeing to know that even I make rookie mistakes every once in a while, which is why careless errors are never a huge penalty on my quizzes and my tests, because I'm more interested in are you capable of thinking through the concepts and the procedures for this particular mathematical phenomenon that we are encountering. And I'm not really worried about, if you go into engineering, you need to be really worried about careless errors, right? Because they can, mathematics mistakes, cost NASA, billions. But we're not working for NASA, so I don't really care. Now, 3/8 is obviously my a value, and I'm going to multiply that by sine of 101, right? And then I'm going to divide that by this 0.9, and I get 0.409. Now, it's that value that needs to have the inverse sign taken of it, and I am left with a is approximately 24.136. Now, c is 101, so b obviously is 180 minus a minus c, and when I do that, what I get is 180 minus a minus or minus C minus A, and I get B is approximately 54.864 degrees. And that winds up being reasonable. And if I wanted to, well, yeah, we have time. Let's do Malvai's formula, okay? And let's see whether what we have here is reasonable or whether it's not. So 24.136. Now, remember, and I introduced this in the last video, Malvai's formula is A minus B over C, and that should be equal to sine of half of A minus B over cosine of half of C, right? That should be a 2 down there. All right, well, let's go ahead and let's deal with the left-hand side of that real quick. Now, I know that I have A stored into A, and I have B stored into B, and then I can, of course, divide that. And, 3/8 minus 3/4 is negative 3/8, which is why it looks like that, because it should. Let's go ahead and go, gosh, it's way up there. Okay, let's go ahead and divide by our C value, and let's go ahead and just remember that, negative 0.417. Now, what I need to do is, let's go ahead, unfortunately, I have stuff already plugged in for A and B, so I'm just going to go to D, E, and F down here, since those run just right under A, B, and C, and I'm going to store the value for angle A into D, into D, because it's right below A, and then I'm going to store B, which is right there. I'm going to store that into E. Okay. So what I need is the sine, okay, and I need D minus E, so that's over 2, and that's negative 2.6. Now I need to divide it by this cosine, and that's cosine of 101 over 2, and I get 0.636. Now, did I do that correctly? Okay. Now, the only other option is and that's not, I wonder where I went wrong on that. Okay, well, let's try that again. Okay, let's do just the big one right here, and we're going to ish it because I don't want to deal with it. So let's do 24.1 minus 54.9 over 2, and then we'll do cosine of 101 over 2. Ah, there we go. Yeah, I don't know why that... Oh, because I didn't divide it. Duh. So what I should have done is take that and divide it by that. And I do get the same thing, all right? It's roughly the same. And since I was ishing the values, that shows me that, that basically what I have here in terms of these measurements that I've arrived at do indeed conform. So basically what I had here is, both of them were roughly negative 0.416 or 0.417. Okay. And that confirms using this, I'm trying not to pronounce it in the German way, Malvai's formula, confirms the fact that the values I've arrived at are indeed legitimate. Okay. Now, let's go ahead and move on to the one where I kind of balked at it earlier. And there's actually two ways that you can think about this one. Now, what they're asking for is they're asking for the area of this shaded region. Okay? Now, here's the thing. Let's talk about it this way first. notice that if these are indeed centers, and I'm assuming that they are because I wasn't told otherwise, basically what I have here is I have a sector of a circle, okay? And that sector makes up part of the square. And so basically the area of the pink region, okay, is equal to the area of the square minus the area of the sector. And then if you're looking for both of those shaded regions, you simply have to take this answer and multiply it by 2. That's it, okay? Now the area of the square is obviously 64. The area of the sector, well, if that's a square right there, then if that's a square, then that's a right angle, and that's 1/4 of that circle. And therefore it is 1/4 pi r squared. And that means that it's 64 minus 16 pi, or 16 times 4 minus pi. And in order to get 2 of them, basically your area of the shaded region is simply 2 times that, so it's 32 4 minus pi. And if you were to plug that into your calculator, now 4 minus pi is going to be a little bit less than 1 because it's 4 minus 3.14159. So you go 4 minus pi, and then you multiply it by 32, and you're left with an area of approximately 27.469 units squared. Now, that is relatively simple. Now, if you don't see that, there's still another way to arrive at that conclusion, okay? And the other way is to basically chop that thing in half by running this right here. Now, if that's the case, then basically I still have a sector, so let's still call it that, okay? I still have a sector of a circle right here, but I also have a triangle, and that triangle will leave out that piece. Okay, so if I want the area of the orange, okay, the area of the orange is equal to the area of the sector minus the area of the isosceles triangle. And that isosceles triangle, okay, let's do the area of the sector. We already know the area of the sector. It's 1/4 pi r squared. The area of the isosceles triangle, this isosceles triangle, is basically half the square. So it's just half of 64, right? So the area of the orange region is going to be that's going to be 16 pi minus 32. Well, the area that I'm looking for is these, right? I'm looking for the 2 regions right there. So if I'm looking for the area of the shaded region, what they call the shaded region, I'm looking for the square minus 2 of those orange slices. Okay? And so the area of the square is 64, but then I need to subtract 2 of the 16 pi minus 32. That becomes 64 minus 32 pi plus 64. Let's go ahead and call that 128 minus 32 pi, or 32 4 minus pi. And gosh, doesn't that look familiar? Okay. And here's the thing. I mean, these are just, and this really wasn't trig based, this particular problem, but it's all part of that sort of swirling mass of geometry as it involves triangles and as it involves the areas And basically, this is an example of a question which drives home that geometric principle that oftentimes when you need to find an area, you need to subdivide stuff, right? And oftentimes when you're looking for the area, it's oftentimes the whole minus the whole. Okay. That's it for this particular one. Those are the two problems that I kind of passed over real quickly because I had a synapse misfiring and I wanted to come back to them and show you both of them, and of course, obviously, try to emphasize the value of both of them. I'm going to go ahead and I'm going to move on in the next video, which is going to be an optional video. I'm going to show you how a lot of the principles that we've been doing with right triangle trig and even oblique triangles will help us find formulas for regular polygons. And that is something that certainly will come back to benefit us as we move forward. So I'm gonna put that up there. Of course, I'm gonna leave that video up there for when we have need of it in the spring for certain calculus applications. Okay, but if you want to watch them now, I'm not going to stop you because it certainly is germane to our discussion of trigonometry and of trigonometry of oblique triangles and that whole shebang. So if you have any questions, please do shoot me a message or an email. Bye.